The gel coat that we use on our boats is a high quality straight isophthalic gel coat, which is very resistant to osmosis blistering. Right behind the gel coat we use a vinyl ester resin below the waterline to give us an additional insurance protection against osmosis blistering. Beyond the gel coat and the vinyl ester resin, we have our laminating resin, which we use a blended resin, which prevents heat distortion, post-curing exotherm on the outside of the hull, and it's almost as good as a straight ortho, which has high strength characteristics, but as the boat ages you'll see distortion on the outside of the hull using that resin. I'm going to tell you about the types of materials that we use to construct the Seaward Eagle. This right here is biaxial fiberglass, which is unidirectional fiberglass, which is this material right here. By contrast, this is material we don't use anymore. This is called roving, and it has little holes between each weave which store resin and increase the resin content of fiberglass. In order to make the boat lighter, we use this unidirectional fiberglass, which is a very tight weave. It has no holes to store resin. Therefore, we can get more glass fiber per resin unit. The coring material that we use is called the Vinicel. It's a PVC foam, and it's impervious to water. You can submerge it in water for years at a time without it soaking up any water at all. And we use it between laminates below the water line for rigidity strength. The second coring material that we use is above the water line, and it goes basically from the water line up to the top of the shear. And it's also a fiberglass material. It's microscopic fiberglass beads. We use the same resin to wet this out as we do the fiberglass itself. And it is a veil. It's used as a veil to protect the gel coat from the look of fiberglass on the outside of the hull. It also gives the boat rigidity and strength with less weight. We're standing inside of a Eagle hull, a bare hull. This is before the deck is installed, before the interior liner is installed. And I'm leaning up against the daggerboard trunk. It's important to point out that the trunk is molded directly to the hull. It's part of the hull. It's not a separate piece that's installed inside the hull after the hull is made. It's all laminated at the same time, so we got chemical bonds and we've got interwoven fiberglass, so it is part of the hull. It is an extension of the hull. The keel is inserted, of course, through the deck and then through the trunk. But the trunk here is cut when the deck goes on, and the top of the trunk is fiberglass to the deck. So they also become one with the hull. But in the case of the keel trunk, it's the compression from the mast is delivered down through the trunk, so this is also a compression post. And though it's not it's not integral to the deck like the trunk is integral to the hull, that's all we have is compression strength. All we have is compression forces that are coming off of the trunk, so it's easy to accommodate a good bond. This part of the keel is the torpedo, and it's lead filled, and we actually have lead going up about to this position right here. This area from here to here is the part that will hang down below the hull, and it's foil shaped, a NASA foil shaped. for best windward performance. And the top of the keel is rectangular. From this position here all the way up to the top is rectangular, so that it can fit inside the trunk, which is also rectangular, without slopping around. It only has an 1/8 inch of tolerance, so there's very little motion of the keel inside the trunk. When the keel is in the full down position and this foil shape is protruding from the bottom of the hull from here on down, we still have this much keel from here to here, which is inside the boat. And as the boat heels, this is the lever arm that is supporting the rest of the boat, the rest of the keel, that is. This is simulated hardware representing the actual hardware that we use as blocks for the lifting mechanism on the keel. These are the actual blocks used through which the stainless steel cable is run to create the mechanical advantage required to raise and lower the keel. This is the rated 2,000 pound stainless steel winch that we utilize to raise and lower the keel on the Eagle. The keel that we're lifting is 2,500 pounds. Now the blocks that we're using are rated at 10,600 pounds. The keel winch is rated at 2,000 pounds. However, with the blocks that we're using, we're reducing the pull on the stainless steel cable to 650 pounds. And the stainless steel cable, which is 1/4 inch 7x19 wire, is good for over 10,000 pounds. This is the mast step. Mast sits right here. This is the bitter end of the winch and keel raising cable. If you ever have a battery failure, electrical failure for example, you can utilize your halyard to raise the keel from right here. I have a mast step here for the Eagle, and I have a simulated mast, which is actual. This is all the actual mast step, the actual mast pin, the pivoting pin, and an actual section of the mast. And the way this all works is, as the mast is going down, it hinges on this pin as such until it's horizontal. And of course, the reverse for pushing the mast up.